Hi guys, I'm going to go over simple lighting networks that we commonly use in our animated lighting shows. This is going to be a generalization. I'm not going to go into extreme details of how or why things work. If you want a little more information about that, the FPP Manual goes into a little more detail and is a great resource, but it doesn't get into the total nitty-gritties, but you probably don't need that to do your show. I'm going to go over some basic information about networks and show design. But if you're already familiar with the basics, you can skip to the basic show designs, and I have an index down at the bottom so you could link to it. So this video is going to be about basic network configuration, but I'm also going to go over some FPP settings at the end that'll probably help you out. Some of the items that I'll cover are: do I really need a network? What is a network? Do my show devices need access to the internet? How do I play my show? And then basic network design pros and cons. So, do I really need a network? The quick answer is yes. At first, you're going to need some sort of network to configure your FPP or controller. And almost every show will need some sort of network, but it is possible to have a show run without any type of network, but it is very rare and limited. So what is a network? A network is when you have two or more computers or network devices that are going to communicate with each other. Here's an example of several networks working together. So if you're looking at a YouTube video, you are communicating through several different networks. Your computer is connected to your router, which is part of your home network. Then your router connects through your internet service provider, who then connects through a series of other networks, and finally connects to YouTube. A very simple network that is typically used is something like this. You have your computer and a controller and some lights. Your computer can communicate with your controller over Wi-Fi or Ethernet. Then your controller will convert the network communication to the information that the pixels need in order to light up when you need them to. But there are really only two types of networks commonly used. One that everything is on the same network, and one where you are utilizing more than one network. When you add more than one network, the principle is really the same for each network that you add. So once you understand how one works, then it'll become easier to add others if you need it. So does my show need internet? Simple answer is no. But if it doesn't have access to the internet, then you're not going to be able to update software or firmware on your controllers and FPP devices, and you're not going to have a timekeeping method to have your shows start and stop on the time that you want it to. However, you can add a real-time clock or other devices if you want to do it, so it doesn't preclude you from doing that, but it just makes it a lot easier if it does have the internet. So how do you play your show? So all shows need some sort of player. The player is what drives your show. It tells your controllers when to start playing, when to stop, and what to play, kind of like a conductor in an orchestra. The two most common players right now are Xschedule and FPP. Xlights is not a show player. It's designed for sequencing. Both of these players are almost identical in their capabilities. The main difference is that Xschedule requires a computer or laptop to run your show, where FPP uses a small single board computer like a Raspberry Pi or BeagleBone to control your show. There are several Pi and BeagleBone based controllers that use FPP for the interface, and any of these devices can also be used as the player. The basic pros and cons for each player is: the pros for Xschedule is it's slightly easier to configure, and most people already have a computer. The cons with Xschedule is you need to have a dedicated computer to play the show. It needs to be in a protected location, and routing the cable from inside the house to outside sometimes can be problematic. The pros with FPP: it's more versatile in the location. It's easier to protect from the weather. It's literally the size of a pack of cigarettes, so you can put it in an enclosure right along with your controllers. The cons with FPP is it's slightly more difficult to configure. However, with the developments in Xlights, it's a matter of a few mouse clicks and you can have it configured. So it's not that much more difficult. The other con is if you are not using an FPP based controller, then you're going to need to buy something like a Raspberry Pi to be your show player. Let's go over some terminology so that we're all on the same page. Every interface must have a unique IP address. That's a number like 192.168.2.5. Now, some devices have two interfaces, like the Pis have a WLAN 0 and an ETH0 interface, and they both need to have a unique IP address. If you add an adapter, you might have 3 IP addresses, but that's up to you. Every device should have a unique host name. Host name is basically a human method of referencing something instead of typing an IP address. When assigning an IP address, you can choose between DHCP or static addressing. DHCP is where when the device connects to a network, it will ask the DHCP server, hey, I'm here, I need an address, and the DHCP server will respond and give it an address. Static is where you assign it yourself. If you use DHCP, then the device will get an IP address from the server, which is typically on your router. This is an easy approach, but if the device has not been connected to the router for a while, the next time this device connects to the router, it could get a different IP address, which could be problematic. But you can define everything by host names if you want and not use IP addresses to resolve this, but it might not work in all occasions. You still have to have the IP address defined and the host name defined for this to work. Also, computers and devices like Raspberry Pi and BeagleBone do not have a DHCP server on them, so if the router is not in the same subnet as the device needing a DHCP address, then you're going to have to use static addressing. So if you decide to use a static IP address, it's recommended that you take some precautions so that you do not assign an IP address that's already being used by another device. Every router is a little bit different, so you're going to have to find out how your router handles DHCP ranges and reservations. Routers will typically assign IP addresses either at the beginning of the range or at the end of the range and then work towards the other end. If you look at the device table in your router or use a program like Advanced IP Scanner, you can tell what part of the range your router is assigning IP addresses to, and then use something in the opposite range, but this is not a foolproof method. It will work most of the time, but it's not guaranteed to always work. So here's IP Scanner of my network, and you see here that everything here is 30, 34. This is all in the low range, all of the devices. Now I have some here in the higher range, and these were ones that I statically assigned so that I would not get into that range. So all of these here are at the upper end, but I also took some other precautions that I'll get into. And you can also look in your router. Another thing that you could do is in your router, you can assign a DHCP range or DHCP reservations. So here's my router, and every router is going to be a little bit different, but if you go to the advanced setup section, usually, on mine it's DHCP settings, and you see here that my router is assigning DHCP addresses starting at 192.168.0.20 and ending at 192.168.0.99, so that gives me 79 devices that I could use, and there's no way I'm going to have that many. But you could also do DHCP reservations, which you could leave this alone and let this go all the way up to 254, and then just assign it individually. And the DHCP reservations is that you would assign it by MAC address. So some of them you could pull it up and find your device and then assign the IP address that you want here for it. And then it will keep that reserved for that MAC address. And a MAC address is an identifier for your device. So use one or the other method. Don't use both, but use one or the other method to ensure that if you do static IP addressing, that you're not assigning a number to one that your computer might, that your router might assign it to. Subnet mask. Subnet mask basically is what defines the size of your network. It's commonly called net mask or mask, and it is almost always in residential consumer grade networks 255.255.255.0. That should be your go-to and pretty much stick with. Gateway. Gateway is going to be a device that it's the address of a device that's going to bridge a network that will process some of the more complicated networking traffic. That most commonly is going to be your router, but not always. DNS server. IP addresses are the only way that network devices are actually identified and communicated with. For example, when you type google.com, your computer is not sending out a request to google.com. It will send out a request to a DNS server, which will typically be in your internet service provider, and they might route it somewhere else. And your computer will say, hey, I want to go to google.com. The DNS server will respond back, oh, google.com is at 142.250.69.206. Then your computer will then again return out the request to that IP address. So instead of going to google.com, it's actually going to 142.250.69.206. So it's kind of like the phone book of the internet. Before we get started, we need to get some information on your home network because you're going to need that information when you configure your controllers and FPP devices. The thing you're going to need is your router IP address, your net mask, and the subnet. All devices in your network, like computers, controllers, routers, etc., are given an IP address, and those addresses have 4 sets of numbers to identify them, like 192.168.0.125. The subnet is typically defined by the first 3 sets of numbers in almost all consumer networks. So in this case, the subnet of the device with this IP will be 192.168.0. Now remember the subnet because that's important that you're going to use later. So whenever I say subnet, I'm talking about just that first 3 sets of numbers. There are several ways to get the information that you need, and they are IP scanning software like Angry IP Scanner or Advanced IP Scanner, Xscanner, which is bundled with Xlights. It's one of the tools that's in there, and it works really well for identifying all of your network and configured devices that you have in Xlights. And Command Prompt or Terminal if you're using a Mac. And your router. The router is a little more difficult because you have to be able to get into it and stuff, but you can look at a device table and see it. I would recommend using one of the other 3 versions, but you can use a router if you need to. Okay, I'm going to show you a few ways to get this information. So the first way, if we look at IP Scanner, so you see here that the modem is 192.168.0.1. That's the IP of our modem. And like I said, the subnet mask is going to be the first 3 digits almost always. And you can usually tell that because everything that's assigned in here has a .0 with the exception of the 72, and that's a special IP address there. So you see everything is in that same range. Another method, which is probably the easiest method, is using a command prompt. We'll open a command prompt and type in IP config. And you see here that this will give you your IP address. This is the IP address of your actual computer that you're on. The subnet mask, like I mentioned, is almost always 255.255.255.0. And the default gateway is 192.168.0.1. That is the IP address of your router. If your net mask is 255.255.255.0, then that means that your subnet will be 192.168.0. Now these numbers can change according to your particular network, so just take that into account. So that's how you can get the info that you need. Now we're ready to move on to the rest. Basic network designs. What network is better, Wi-Fi or wired? People ask that all the time. A network is not typically defined as Wi-Fi or wired. Wi-Fi and wired are just the methods that data gets transmitted from one device to the other, and most networks actually handle both methods in the same network, so you can mix and match as much as you want. Configuring the Wi-Fi or wired parts of a network are almost identical. They both follow the same basic principles. There's a lot of opinions and personal preferences on this, and just like about every aspect of our hobby, everyone's got an opinion. But this is like asking what's better, Windows or Mac, Chevy or Ford. You're going to get a bunch of different responses, and everybody thinks their way is the best. At the end of the day, all of those different methods will get the exact same results, making your lights blink and flash. There's quite a few people that insist that a wired network is always better and more reliable than Wi-Fi. Again, those are opinions and not facts. Both methods work very well when properly configured, but both can have failures. One thing to note is using Wi-Fi to send E131 or DDP data can be problematic. But there's a method called multisync. This used to be called the master remote mode. And this is designed to use multiple controllers that communicate via Wi-Fi, and it works very well. I personally run 6 controllers, all with Wi-Fi using multisync with no issues. And there's thousands of other shows that are using multisync over Wi-Fi as well. One person has a light show in a park with 72 controllers that are all connected via Wi-Fi using multisync. So what's the best show design? There are several different methods that you could do. And I can tell you which the best one is. Very few people can tell you what the absolute best one is. But here today, I will tell you what the best show design is. And that is the one that you understand and can make work. In reality, most people actually use a combination of show design concept, and the networking part is fairly straightforward once you understand how it works. I'm going to show you some of the more common methods, and you can decide which one works best for you. Okay, so some basic show designs. There's 3 basic ones: standalone, home network, and separate show network. And in reality, a lot of times people will combine a couple different methods together. So this is a standalone. You basically have a player, your controller, and your lights. The standalone configuration will not have any way of knowing what time or day it is unless you add some sort of real-time clock. So if scheduling is a concern, then you're going to have to make arrangements for that. But if it's going to be always on, then this isn't a problem. And your player doesn't have to necessarily be a computer either. It could be an FPP on Pi and installed in the same enclosure as the controller. This is a common setup used for mobile displays. But using it like this it's going to require you to have access to the FPP device in order to make changes. There's a couple ways you could do it. You could temporarily Wi-Fi or USB tether to it, or you can configure it as a separate show network if your Pi has a Wi-Fi adapter that supports AP mode, and set it to always be on. If your controller is FPP based, then you don't need a separate player and it's a lot more compact. But the same concerns about being able to connect to make changes still apply. But like I mentioned, you can configure it so that you can connect via your phone or other mobile device to make changes. If you're using an FPP based controller, then you can also configure it to output E131 or DDP data to other controllers, so you're not limited to just one controller. This configuration is rarely used, but it is used if it's part of a mobile display or one that's going to be installed where there's no outside network capabilities. The pros with this setup is it's a very simple configuration. The cons are it's very limited capability. It's difficult to access to make changes. You cannot update the controller or FPP without additional work, so it's a little more complicated for the overall usage. So let's go over the configuration for a standalone. So we'll start with the player. Since it doesn't have access to any other device, it doesn't matter because you're not going to have access to a DHCP server, so because computers and FPP devices don't have it, so you're going to have to do a static IP. Because it's a standalone configuration, you can set your IP address to any legal IP address you want. I'd suggest using something like 192.168.x.x. Netmask, this is going to be almost always 255.255.255.0. Gateway, since there's no other device that's in the network that you're going to be bridging networks with, it's not going to be used. DNS, In this configuration, there's no access to a device that has a DNS server, so that value isn't really important. So this is how it might look on the device page. So you'd have the ETH0 set up to 192.168.52.2 with the net mask of 255.255.255.0. The gateway, you could put something or leave it blank. It really doesn't matter. Now we'll look at the controller, and it's pretty much the same. Again, computers and FPP devices typically don't have a DHCP server, so you got to use a static IP address, and it's got to be in the same subnet as your player, which in this case it's 192.168.52. So you can give it any number, 192.168.52.3. Net mask, again, it's almost always going to be 255.255.255.0. Gateway, in this case, there's nothing bridging the network, so you really don't have to put anything in there. If you are, you could put the IP address of the ETH0 interface. In case you expand something future, it'll already be there. So this is how it might look on the controller page. The host name, make it unique. The IP address, 192.168.52.3. The gateway, 192.168.52.2. Subnet mask, 255.255.255.0. And the DNS isn't used. If you had a standalone configuration that the controller was FPP based, same things apply. The DHCP address, netmask, gateway, DNS, none of that's going to matter. If you leave everything with the default of DHCP and your FPP has AP mode, capable Wi-Fi adapter, then you could access this device by using the Wi-Fi tether, or if the device supports USB tether mode, you can access it that way. So there are some ways that you can access it. Here's the home network method. Basically, you have a computer going through a router over to your controller. So this section might get a little bit confusing because we're going to go over a lot, but it's just an example of some options, and it'll make more sense when we get into the next slides that follow. So in this network, you can expand on it. If you have 2 to 4 Falcon controllers, you can daisy chain them like this, and then just do one to the other. If you had another one, you could just connect that over to another one down below. If you have much more than 4 controllers daisy chain like this, it could cause some lagginess. If you have multiple controllers or controllers other than Falcon controllers, then you can add a switch like this. Now this will work with any E131 DDP type controller, and the number of controllers that you can connect this way is almost limitless. In all the configurations shown, you would have to use Xschedule for the player. But if you wanted to use FPP, you'd simply add a Raspberry Pi like this. And with the Pi connected this way, all of your show traffic is going to be isolated to your controllers. It will not impact your home network, and your home network will not impact your show. All the network traffic is going to be isolated through the switch in here. None of it's going to go back into the router. Now you could also connect your computer and have it go into the switch, and then now at that point, if you're using Xschedule anyway, and if you had the computer connected directly to the switch like this, then now your show network stuff with your computer will all be isolated as well. If one of your controllers was FPP based like this, then you wouldn't need the additional Pi. You could use that as your player, and it would all communicate with all the other controllers. So the pros with this setup. So your show will have access to the internet, so it'll have ability to keep accurate date and time. You'll be able to update your controllers and FPP devices, and it's fairly simple to configure the network since everything's on the same subnet. The cons with this is if you're using Xscheduler and the computer's inside the house, you're going to have to figure out a way to route a cable from the inside to your switch and or controllers. Another one is you're going to have to make several cables, so it's probably good if you learn how to make network cables or buy a bunch of custom made links or just coil them up, and sometimes that can be a little messy. The cables might be exposed to critters, and for some reason it seems like rabbits and squirrels think the cables are candy and have a tendency to chew on them. Okay, Now let's get into the actual configuration of your devices. So we're going to use the info from earlier where the subnet of our home network was 192.168.0.x and the router's IP address was 192.168.0.1. Remember that I configured my router to use a DHCP range of 20 to 99, so I can use any number above 99 for my controllers. All of the controllers in this type of configuration are going to be configured exactly the same way, with the exception of the host name and the IP address. You can use the DHCP option or static IP address for any or all of the controllers, but remember the issues that I presented earlier. If you're going to be using DHCP, then you would just check the boxes for DHCP here, and we're going to configure the ETH0 address. We're not using WLAN 0, so you could just leave that the default without anything entered in it. And we're going to enter for the IP address, we're going to do 192.168.0.100. Remember I mentioned about getting out of the range. Net mask almost always is 255.255.255.0. The gateway in this case will be the IP address of your router. In our example, it's 192.168.0.1. And then the host and DNS settings. So the host name, you want to give it a unique name. And then for the DNS settings, the DNS server, one of them, it doesn't matter the order. Typically, you'll point to your router 192.168.0.1. And the other one point to an internet. This is a common one. That's Google's DNS server. That's 8.8.8.8. And that would be the setting for the controllers. If you had more than one controller, then you would the next one would be 100, and you change the host name. That's the only two things that change. The next one, 102, and a unique host name. That's the only thing that would change in this configuration. Okay, now we're going to go over separate show network. You're going to need an FPP device that has Wi-Fi and Ethernet interface. You can do this with two Ethernet interfaces, but it's not a common configuration and it's a little more complicated. And you can use either Xschedule or FPP as your player. The WLAN 0 or Wi-Fi interface will be configured to connect to your home network, and the ETH0 interface will be configured on a different subnet. If you've got 2 to 4 Falcon controllers, you can daisy chain them like this. If you're using multiple controllers that aren't Falcon based, you can add a switch and connect them like this, and this will work for any E131 type controller. Now, if you have one of your controllers is actually FPP based, you don't have to have the separate FPP device acting as a bridge. You could just use that as well, and it gets configured exactly the same. The pros with this is that you will have access to the internet, so it's going to have an accurate date and time. You don't have to run a cable from the inside of your house to the outside if you have your bridging device outside. The cons with it is, in order for this to work, is you have to have a good Wi-Fi connection, and that you still need cables to make. Okay, now we're going to get into the configuration part of this. We're going to assume that the home network is the same as in the previous example, so your router's IP address is 192.168.0.1. And this configuration is really very similar to the home network configuration. We just need to create the bridge to get to the additional network. We'll start with the FPP that provides the bridge to the separate network. And on that, the WLAN 0 will need to be configured to communicate with the home network. The ETH0 will need to be on a different network. You can use the DHCP option or static IP address for the WLAN 0 interface, but remember the issues that I talked about earlier. Like I mentioned, I set the DHCP range in my router to be 20 to 99, so I'm going to give the WLAN 0 interface of this device 0-100 to get it outside the range. You're going to have the net mask set. The gateway is going to be the IP address of the router, and you'll need to enter your SSID and password. The ETH0 interface will need to be in a different network than the WLAN 0 interface, and it has to be a static address. You can't use DHCP for the ETH0. I typically use the last set of numbers, the 100 here, to be the third set of numbers in the other one for that subnet. And it makes it a little bit easier if you have a whole bunch of controllers, and I'll show how that works. So I have the ETH0, and I use the last number from the WLAN side, and then I just start with 2 typically and then move up from there. Then you'll have the net mask, and the gateway you leave blank on the ETH0 side. Okay, now that we have the ETH0 network defined, we need to tell our home network how to communicate with the show network. For security purposes, a network cannot normally communicate with another network unless you specifically configure it to do so. There are 3 basic ways to do this, and they all give the same results. There's advantages and disadvantages to each method. You have the proxy host method, the route in computer method, and the static route in router method. The proxy host is probably the simplest of them all. You just define the proxy host in the FPP device that's going to bridge the network, and then you tell Xlights that you're using the proxy host by filling in the address so that Xlights can access the device as well. So we're going to set up a proxy host on the device. Okay, so this is the Pi that's going to be bridging to an F48. So you go to Status Control, Proxy Settings, add the proxy host, and then you enter the IP address of the device that you are proxying to. In this case, it's going to be 192.168.103.3. And if you remember how I did the numbering, if you look at the IP address of here, it ends in 103, so the device is going to be on a 103.2, and then I just do 103.3, and it makes it a little bit easier to follow. And then once that's set, then you can get to the device by clicking on it. And if you see, you've got access to it now, but you have a weird IP address. You can't just type in 192.168.103.3, which is the address of this controller. You have to go through this proxy address. Now you also have to add the information into Xlights. So here you see that we have all the controllers, and you would have to enter each one individually. Just like in FPP, for each controller, you would have to enter one. And you would put the IP, and this would be the IP address of the wireless side of the Pi. So it'd be 192.168.0.100. Now, and then you'd have to do that for every controller here. But if every controller is on that 100 subnet, you can do a global proxy. Now you only want to do one or the other. So if you click on an empty spot here, you can do the global proxy, and you can enter it there. And then that will give you a proxy for all of these, and you don't have to do it. But then again, only do it in one location. The pros with this is it's very simple to set up. The cons are that not all controllers support the proxy host method. All of the culplights.com controllers and all the Falcon controllers with the newer firmware support it. In order to access the controllers directly, you have to use a strange IP address like I showed you. You just can't type in the browser directly. The second method is configuring a route in your computer. So you're going to open a command prompt as an administrator, and then you're going to type in on a Windows computer route -p add 192.168.100.0. This is going to be the network that you're bridging to, and notice a 0 at the end. You don't do individual device, you do the entire network. Mask, almost always that number. And then the last part is the address of the device that's going to be doing the bridging, and that's the WLAN 0 IP address that you have there. If you're using a Mac, you're going to type in sudo route add, and it's essentially the same thing, the network. Now, the part that's a little bit different, -24, that's a different way of indicating the subnet mask, and that's the same as it as 255.255.255.0, and then the device that's bridging it. And that, as you see, is the WLAN 0 address. And then you have to, on your FPP device, you have to enable the routing. So you would go to your FPP device and go to Status Control Network and go to Interface Routing, and then enable the routing between the network devices. So that's on the device that's bridging it. You have to have that enabled for anytime you have the routing from an external source, like from the computer itself or a router. You have to have that enabled. The pros with this is it works with all controllers. The cons are it only works on computers that have that route configured on it. So if you go to access it from a different computer, you're going to have to put that route on that computer as well. It will not work on mobile devices because there's no way to set up routing in the mobile devices. And Macs do not have a persistent option, so the route will have to be re-entered if the computer is turned off or rebooted. The last method is configuring a route in your router. This is actually my preferred method. So I'll show you how you do that. Okay, so let's log into our router. And it's typically in the advanced setup section. And if you look here, you've got routing. So it's going to be static routing. And so the destination IP, it's going to be the same as we did before, 192.168.100.0. Remember the 0, that way it goes to every device. Subnet mask, almost always that. The gateway IP, that's going to be the WLAN 0 address of your Pi. You see, by using that numbering convention, it makes it easy to remember. Apply, and that's going to enable the routing. And with that, you also have to make sure you have that box enable routing on FPP in the interface setting. So the pros with this is you can access your controllers through any computer or mobile device. It works on all controllers. About the only con is that some routers do not support routing, or for some reason you can't get into the router. Now that you have your main FPP configured, the rest of the controllers are configured almost exactly like the home network configuration, except that the gateway will point to the ETH0 address of the main FPP. So we would configure the controller something like this. You're going to have the host name going to be unique. IP address, we just started with the next number from here. The gateway is the address of the ETH0, what it's connected to. Subnet mask, primary DNS, this would point to your router, and secondary is 0000. If you had another controller, everything will be the same with the exception of the IP address. You just change this IP address to be the next one, so 3 and then 4. And it really doesn't matter if you're connected directly through a switch, the configuration is exactly the same. Nothing changes, it's just the way the wires are routed. And if you have a controller that's FPP based, then you can use that device for the bridging FPP, and it's configured exactly the same as the Pi was. No difference, it's just a different device. And you eliminate the one FPP device. So the WLAN 0 still the same, ETH0 still the same. Another very common method that people use to control their lights is the multi-sync method. It isn't really a different network configuration, but I'm going to cover it just to be clear. The multi-sync method is configured exactly the same as the home network configuration, but it typically uses Wi-Fi communication. You can keep the switch and cables if you want, but you really don't gain any benefit by doing so. The difference is how FPP is configured. The data packets that FPP sends in multi-sync mode are very small, so it won't impact your network. This method requires a controller that supports a remote mode and Wi-Fi capabilities. The Cope-like line of controllers works especially well with this method, but if your controller doesn't support remote mode, like the older Falcon line of controllers or other E131/DDP based controllers, you can still use the multisync mode. You'll just need to add an FPP device like a Raspberry Pi, and this is a common practice. So you could have it just configured with the Pi acting and then connected to the controller. Any of your FPP devices can be designated as the player, and it really doesn't matter which one. It just needs to have the multisync enabled, and I will demonstrate that in a minute. The player will be the device that you configure your playlists and schedules, and the device that will play the audio. The rest of the devices will need to be configured as remotes, and you'll need a copy of the sequences stored on them. You don't have to have a dedicated player. You can use one of your FPP-based controllers to be the player. So now we'll get on to the configuration. The IP addresses on all of the FPP devices will be configured just like we did in the home network configuration, except they'll be on the WLAN 0 interface. So the configuration will look something like this. Notice the WLAN 0, the IP address is in the same subnet as the router. The net mask, same as standard. The gateway is the router IP address, and you're going to put in your SSID and password. And you really should use the 2.4 gigahertz network because it travels through walls better and it gives you a better range. There usually isn't anything that the speed of the 5 gigahertz will give you an advantage. So if you have an FPP device that you're using as a remote to send E131/DDP data to a standalone type controller, like the older Falcon line of controllers or other E131 like we have here, then you'll configure this FPP just like you would on the separate show network with the ETH0 configuration. The ETH0 will need to be in a different subnet. As you see here, it's in a different subnet than the WLAN 0, and it'll look something like this. And you see here that we have the IP address, net mask, and no gateway. And like I mentioned, you'll need to configure some sort of routing like I demonstrated in the show network section. And on your FPP device, you'll have to enable the multisync. And you can do that in one of two places. You can go to Status Control, FPP Settings, and go to the System. And you can enable it here by sending multisync packets. Or you could go Status Control, Multisync, and go to Settings, and you can enable it here. And the multisync page is kind of a neat page that you can see all of your connected devices. So that's the configuration of it. If you have more than one controller that you need to use a Pi to communicate with the player, like we have here, several that are branching, then each Pi ETH0 address is going to have to be on a unique subnet, and you're going to have to configure the routing on each device. So here we have the WLAN 0 is 192.168.0.100, and like I mentioned, how I like to use the 100 for the third here. So you have 192.168.100.2, and this is .3. For me, it makes this scheme real easy to remember because I know that if I have a .100, that the ETH0 of this device is going to be 100, and because it's the first device in the chain, I start with 2 because 1 is usually reserved for routers, and I like to kind of keep that practice. And then this one will be 3. Same thing here. This ends in 101, so the subnet going to be on this one 101.2 and then 3. For me, it makes it easy to remember how that all works together. All right, let's go over the FPP input and output settings. A common mistake that people make is in understanding and configuring the inputs and outputs of an FPP device, and then they have problems with lagging or poor quality playback. Hopefully this section will clear that up a little bit. The good thing is that if you properly configure your controllers and X-Lights, when you upload the configuration to your FPP devices, your outputs will be configured properly. Unfortunately, right now the inputs doesn't get configured and you have to do that manually. It doesn't matter if you're using wired or Wi-Fi connections. Inputs and outputs have the same concepts. Now, one thing just remember, sending E131 DDP data over Wi-Fi can be problematic, so just be careful with that. Let's start with the inputs. Inputs are used when you want a particular FPP device to process incoming E131 DDP data. If you're using Xschedule or an FPP player to send E131-DDP data to play your show, then your FPP devices are going to need to have the inputs enabled. DDP data does not have universes. You just need to enable the inputs, but if you're sending E131 data to the FPP device, then you're going to need to configure only the universes that that FPP is going to use. Here's an example of a home network configuration using Xschedule as a player. One Falcon is going to be using E131, and for demonstration purposes, one K8 is going to be using E131, and the other K8 will be using DDP. Each FPP device will only need inputs configured for the data it will be processing. So the only one that's going to be processing any data is this one. This one is DDP, so it just needs enabled, and this one needs to be configured. So let me show you how you do that. So you got to look at Xlights, and you got to look at the channel configuration. So the one that we're going to configure is this one here. So it has 12 universes. Remember the 0, you got to count that one, and it starts at universe 300. The start channel is 10753, and we are not doing multicast. It's recommended to use unicast unless it doesn't work properly. And channels per universe is 510. So you have to remember what that is. Once you have that identified, then you pull up your FPP and go to your inputs. Now, if this was the one FPP that had just the DDP data, enable the inputs, and that's all you have to do. But because we're going to configure the other one that's getting the E131, we have to do it, and you only need one input. Set that. It's going to be unicast. The description, you can put a description or not because it's just the one input for itself. It's probably not needed, but if you need to do more than one input, then you might want to do it. The start channel is going to be 10753. Universe number is starting at 300. Universe count is 12. And the universe size is 510. So once you have that, save it. It'll ask you to reboot. And if you look, it's going to give you an end channel here. So you want to verify that that's correct. So that's 67872. So let's go back and make sure that it matches what Xlights has. 16872. So it matches. So you got the configuration right. So that's how you would configure the input in that situation. One thing I want to go over is you want to set your bridge priority. And what that is you can have it set up for, go to FPP settings, and go to input output, and you have to be in, let me go back, you have to be in the advanced user interface level to get the input output. Go into the input output, and the bridge data priority, this kind of tells you, it says how to handle the bridge data when it's received. So if there's a possibility that you're going to be playing a sequence or testing from Xlights is going to be bridging. So you want to set what the priority is with that. In this case, these devices in this situation are just going to be using bridge data. They're not going to be using anything else, so you want it to be prioritized bridge. Okay, so now let's look at a separate show network configuration. So in this case, the F8s will be processing the E131 DDP data exactly the same as we did before. So the configuration is going to be the same. I'm not going to go in that because we just went over it. The FPP device that's running the show, it's not going to be processing any inputs because it's going to be running the show and doing the outputs. The communication through Wi-Fi is just for configuration and access for the controls of this, but it's not actually sending any data. The data for the show itself is going to be coming through here. So that doesn't need any inputs configured. But if you want to test from X-Lights, then your FPP will need to have the inputs enabled, and this time one for each of these controllers. Now, when you test from X-Lights in this situation, because you're going over Wi-Fi and sending DDP data, just be aware that it's likely to have a little bit of lagginess and glitchiness. You always want to test your actual thing from the show player. So if we want to test from X-Lights, because it's only going to send DDP data, then we need to configure this FPP device for inputs. These here will have the inputs, like I said, configured exactly the same as before, so we're not going to go into that. So just to refresh, we'll need to go in. We'll have to get our universe, start channel, number of universes, and the channels per universe. So the F16 V3 was 512 channels per universe. Started at universe 121. The K8 started universe 300 with 12 universes, started at 10753, and because this one's DDP, we don't have to worry about it, just enable it. Now, if you notice, I mentioned that this one's 510 and the other one was 512. It doesn't matter which one you use. Either one will work, just all the devices have to know the same thing. So if one device is configured for 510, then X-Lights has to be configured for 510, and the inputs and outputs have to be configured for 510 for that device. Okay, so once we got that data, then we'll go into our FPP, and this one here, you'll probably want to set up the prioritized sequence, because if you have a sequence playing and you accidentally press the output to lights in X-Lights, you don't want it to override what's going on. So in this situation, you probably want to have the prioritized sequence, and that way it'll ignore incoming DDP data. I mean incoming E131 or DDP data if a sequence is playing. If a sequence isn't playing, then it'll just work. So here on the inputs, we'll go to the inputs. We'll need to enable it. And we're going to need two different lines because it's two different devices. And here's where an explanation might help. So the first one is going to be the F16. And if you have more than one of a similar device, you might want to name it. The input type is unicast. The start channel is 1. Universe was 100. Universe count was 12, and the universe size was 512. I'm sorry, universe count was 21. It ends at 10752. Okay, the next one is going to be the K8. It's going to be unicast. The start channel for that is going to be 10753. And if you look, that matches up with here. So the end channel here, if you don't have anything funky going on, usually will be the start channel here. Not always, so just verify it when you get into X-Lights. The universe here is going to be starting at 300. Universe count on this one is 12, and the universe size on this one is 510. Remember, I said this will work just as long as everything in X-Lights, the K8 is configured for 510, and the controller is, and the inputs. So this one will be configured like that. Save it, and you're done. You're going to have a similar situation if you're running in a multisync mode, like this. So in multisync, they're not processing any inputs at all. It's all multisync data, which is not E131 or DDP data. So you don't need to configure inputs on any of these devices. So in order for it to work, no inputs are configured. But just like before, if you want to test from X-Lights directly, then you're going to need to enable the inputs and configure them in FPP, since X-Lights will only send E131 DDP data when you select the output to lights. And you're also going to need to set the bridge data priority. So in this case here, the input will only be what the F16 is going to process. The input for here is only going to be that one. This one's DDP, so you just need to enable the inputs. We covered this already, so I'm not going to go into detail, but just so you know, the inputs is going to be what this device is getting. The inputs for this one is just this one, and this one you just enable the inputs. Okay, now we're going to move on to the outputs. Configuring the outputs incorrectly is a common mistake people make, and this can cause all sorts of problems. Sometimes it's due to people not understanding how X-Lights and FPP Connect work, and they use the wrong settings. So you only configure the outputs when you need to send E131-DDP data to another device. The E131-DDP output is not the same as pixel port outputs. In this diagram, we have a very convoluted output. This isn't a common configuration, but used to explain how the outputs would be configured, and it covers just about any scenario. So you have an FPP device that is a player. It will be outputting E131 data directly to the two F16s, but then the player will also be sending multisync packets to the K8 and the Pi that is connected to the F48. Multisync is not configured as an output, but as a setting, and the other FPP remote will be sending E131 DDP data to the F48 itself. So to recap, you're going to have the player sending E131 DDP data to these two devices, and this device is going to be sending E131 to the F48. So only two of the FPP devices are going to be sending outputs, and it's going to be a little bit different. So let's show how this will be done. So first we'll pull up X-Lights. And like before, you have to pay attention to all of the settings. So we see that the F16 Megatree, and maybe write it down or open a screen on top of it. So you see that it has universe 100 with 21 universes, starts at channel 1, ends at 10752, and it's 512 channels per universe, and it is not multicast. And like I said, unicast is usually the preferred. Same thing, you got to note what each of these are. It's going to be starting universe 200, start channel 10753, end at 13812, and 510 channels per universe. The F48 yard, which this one's going to be proxied, is going to be 300 to 311. So that's 12 universes, start at 13813, end at 19956. And we have the proxy host in there. And then the last one, the K8B matrix, because this one is running by itself and not having any outputs to it, you want to set it up here as X-Lights only. That way it won't configure outputs when you send the data. So now that we have that written down, then let's go to the player and show you how that works. So here's the player. Go to the input outputs, the channel outputs. You would enable the output. You're going to set the output count to 2, because you're going to have 1 for each of the two F16s. And you're going to set it appropriately, but we're not going to set it. We're going to let X-Lights do that. So let me show you how that works. So we're going to pull X-Lights back. We're going to go to Tools, FPP Connect. And we're going to only select that device for now. UDP out, we're going to set to all. And we're not going to have any sequences, so let me clear the selection. So then simply upload it. And let's see what it looks like. So refresh the page, and you see it's enabled. You've got the X16V4. You see it's got the starts at channel 1, universe 121, 510. The F16 is done. Now the one thing here is it does have the F48. With this, you have to just disable that one. That's one thing that you manually have to do in a situation like that, is sometimes it'll upload more, and as you notice it did the K8B matrix and it didn't enable it. So you just want to check that it didn't put something extra. But other than that, you look, all the end channels are correct. So you're going to save it, restart FPP, and it's done. So then we're going to go to the FPP device that's bridging the data. This one here. Like I said, we only have 2 that's going to be doing output. So let's go to the F48 bridge Pi. And here, let's go to the outputs, channel outputs. And if you remember, that one started you'd only need 1 because it's only going to be for the F48. And it's going to start at universe 300 with 12 universes. But like I said, we'll let X-Lights do it, and then we'll just verify. Tools, FPP Connect, and we only need that one. Now, because this one is used as a proxied host, it actually works out a lot better. So we'll select the UDP out as proxied on this one, and when it's set up as a proxied, it will select only the universes that it needs, which is a nice feature. It'd be nice if the other one, instead of doing all, that there was another option. So let's see what that Pi to F48. So we'll refresh the screen. And you see now here it has the F48 unicast. Let's see, the start channel 13813 is correct. The end channel 19956 is correct. Universe 300, 12 universes, 512 channels per universe. So that looks good. So you see that the FPP Connect does it correctly. The last one is this FPP device, and because it is in a multi-sync mode only and it's not outputting to another device, there's nothing it's connected to, you don't enable any outputs at all. So that pretty much covers everything that you need to know for networking and some of the output configurations. So hope this helps you out, and have a good day.